Everybody, welcome to my RCA workshop. Today, my name is Gordon. I'm the consultant from Precision RCA Consultant Limited CEO. Today, we are trying to introduce one of the precision RCA method that could be solve a problem, pinpoint the root cause quickly as possible. This RCA workshop will be focused on one of the RCA case we have done before. This problem is focused on one of the screw compressors, which you can see from the leakage trending here. It increased dramatically from 2013 and almost increased 2.5% for natural gas, and huge increase for natural gas, increased from 1.5 tons per day to 11 tons per day. So totally CR gas will increase almost 4 times for these compressors. So there'll be a big gap here. You can see the efficiency of compressor also reduced dramatically by 15%. So two compressors have to run at the same time. And also this company spent about 2.6 million maintenance cost in 1 year. And the problem is still there. So let's looking at the design of this screw compressor and the shaft seals for these compressors. You can see that this compressor is a twin screw compressors with 4 shaft seals. On the right corner, you can see the 4 setting point for this shaft seal. The left one is for natural gas. The middle one is a leakage of gas, and after that one is natural gas. And also you can see like a C1, C2, C3, C4, the leakage points. Later on will be used those leakage point clearance to determine what is the root cause, why the setting gas is increased so much. So in this RCA case studies, we use one of the formulators, which is called the leakage rate per unit times. We formulate the formulator 2 of this. From these formulators, you can see that the leakage have a promotion to the radius of the sliding phase and the power 3 or clearance, and then times the pressure differentials, and then divided by the viscosities and also wideness of the setting phase. And from these calculations, we can easily find that C1 which increase a lot from 13 tau to 24 tau. Before these calculations, nobody looking at this how much leakage will be increased. But after the calculation, you can find just at the point the leakage will be increased by 8 times. And we are assuming here that the leakage point is 50%. So just let the point deviations will result in 400% increase of leakage. And from this calculation, we can make a quick conclusion here that the leakage of the gas circuiting is coming from the increase of clearance. From these calculations, we can easily find the root cause, and then from that root cause, we can give our recommendation and then see what result come from that. Our recommendations is to reduce the C1 clearance from 24 tau to 12 tau. Then we order 2 spare whole set of carbon ring, one the second compressor over there. The result is after just 1 month overhaul, these compressors come back to the site with leakage only 7.5 tons per day. As we know before, the design is 7 tons per day. So it's a big improvement, reduced for the setting gas. And also we reduce the natural gas usage from about 6,000 tons per year, reduced to 2,738 tons per day. and also a huge reduction for nitrogen usage from about 4,000 tons per year to 447.5 tons per year. So this is saving a lot of money for those sitting gas. And also, like the saving for running one compressors is about $1 million per year. So it's a very successful RCA. And from the RCA until the overhaul end, the total duration is about 3 months. Yeah. Now let's talking about this precision RCA method benefits here. From this RCA case, we are pinpointed the root cause very quickly. We are find the root cause just in 1 month, and reduce like the manpower to do RCA at team over there. Because before we almost do RCA every year, and we build a team of 6 or 7 people. You know how much time and how much money will be spent on that. And also, we reduce the data needed to collect to the minimum as well. But before, when we do RCA, we always collect all data, operation data. We know that we don't have a data from design company or manufacturers, but from operation data, you can collect many of the data, but it's also consume a lot of time over here. And also from this RCA, we learn a lot how the mechanical cells working principle over there. And also we help operation and the maintenance. We can monitoring the performance together. And also like before the RCA, our turnaround is always is time-based. So every 2 or 3 years, we at the last stages, every 2 months, we need to do the turnaround overhaul for this screw compressor. And now we are based on the leakage of gas flow over there. Based on this flow amount, we can adjust our overhaul plan. Yeah, it's also reduced a lot of unnecessary mistake bring from the unnecessary overhaul as well. So from this RCA case studies, we can find that if we use our engineering knowledge or the calculation from our study in the schools, we can pinpoint or find out the root cause as quickly as possible. And if you have interest, if you have any like chronic problems, you need some quickly and precision RCA support, you can contact me. My cell phone here is 001-587-938-7708. You also can email to me, and also if you have interest, you can come to open the website. And if you need any help, just contact me. Thank you, everybody.